Scholars. Welcome to another live CSEC math class. This evening is our formula evening. Today is Thursday, and so we are going to be looking at the volume of a cone. So stay tuned for that. Before we dive into that, here's our schedule of live classes. Please be reminded that we have 5 live PEP classes per week, and we have 6 live CSEC classes per week, including our midnight oil multiple choice paper 1 CSEC class on a Thursday night. That's tonight. So if you want to join us tonight, just come back at midnight and we'll be working through 60 multiple choice questions. So here's a schedule of classes. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. Right. Okay, so welcome Imani. Good night, Miss. Welcome John. Welcome Asar. Asar, are you there? All right, so Asar logged off. I think something is wrong with his mic. So he's gonna try back. Asar? All right, so while Asar sorts that out, we're going to... Okay, can you hear me now?
Yes, miss.
All right, good night. So let's share our screen. So it's volume of a cone. And what do we mean by a cone? So we've all had ice cream from a cone, right? The ice cream cone. It's like that. That's the cone itself, and then you have the ice cream on top of it. So this is the cone. Huh? Not seeing the screen?
Yes, miss, we're seeing it. The ice cream
Okay.
mechanic.
What were you saying?
Don't put it yet. Miss, I'm right now for formula.
Oh, you're writing out the formula. Okay.
Yes,
So the formula for finding the volume of a cone is 1/3 pi r squared times the height. Does any part of this formula look familiar to you though?
Miss the pi r squared because of the circle at the base of the cone.
Okay, so you're saying the pi r squared part looks familiar. That's the area of the circle.
Yes, miss.
Any other thing about this formula looks familiar? The
Miss
area,
the area of the cylinder.
is it area of the
Miss the volume
cylinder?
of the
Volume.
cylinder. The
The
volume.
volume, right? The volume of the cylinder. So look at those two then. So here we have the cylinder. The volume of the cylinder is pi r squared times the height. The volume of the cone with equal radius. This is if the radius is the same, the height is the same, right? So a cone with a similar height and radius, the volume is 1/3 pi r squared. How do these two formulas compare then? Are we able to say the cone is that number of times the
Yes, miss. The
cylinder, or
cone
the
is
cylinder is that number of times the cone in terms
yes,
of volume?
yes, miss.
What are we able to say?
That the cylinder is 3 times larger than the cone, or the volume is normally 3 times larger, and that the cone is 1/3 of the cylinder's volume.
Okay,
Or
right. So that's the first thing we're going to prove for ourselves. That's the first thing. The volume of the cylinder with radius and height being equal, the volume of the cylinder will be 3 times the volume of the cone with similar radius and height. Or put another way, the volume of the cone is 1/3 the volume of the cylinder. Let's see if that's really the case. So let's see, this is a cylinder, and let's say the radius is, just use some small numbers, 4 meters, and let's say the height is 6 meters.
Mr. Graduate,
Let's work out the volume
Mr.
of that
Graduate,
cylinder. Sure, John. So the
yes,
volume would be what?
pi r squared times the height.
So so pi r squared times height, and pi is what?
This height, this
Pi
height is 6 meters. Height
3.14,
6 meters. Pi.
and
Pi.
the radius will be
Basic. The 4 meters per meter.
4 squared,
The height
and the height is,
is the height is
so what's 4 squared is what?
is squared 6 meters. But times 6
So
meters.
work out 3.14 times 16 times 6.
Okay.
What does that give us?
It's like
Hmm?
it's like
You plug in those in, John?
it's our count.
You're working it using the calculator?
Miss.
Well, you don't necessarily have to use it. This is not a multiple choice question. You can use a calculator.
If I was using a calculator because of that.
All right, go ahead then and tell me what you get when you get it.
It's about 301.44 meters.
301.
This is per meter.
301.44.
Yes.
And what's the unit?
This meters cube.
Meters cubed. So remember, volume is measured in cubic units. So, so we said the radius was 4, the height was 6. So that would be the perpendicular height, straight line down from the apex to the base, not the slant distance, the perpendicular height, and the radius would be the same 4. So let's work out the volume of this cone now. 1/3 pi r squared times the height. Or Asar, you do this one.
Okay, miss. So the volume will be equal to a third times 20 times 22/7 times the radius, which is 4 meters squared times 6.
All right. What would that give?
Um, it will give 99.48
99.48 units
meters cubed.
meters cubed. So given the same radius and height for the cone and the cylinder, so let's check. So divide 301.44 by 99.48, just to check if it's really the case. How much you get when you divide it?
Yes, miss, it is because we
Is
found
is 3
third.
3.0 something, right? Yeah. So we could round this to 100
Um,
for ease of the experiment, and round this to 300, and we see that 300 divided by 100 is 3. So that's a given. If you have a cylinder and you have a cone, they both have the same radius and the same height. The volume of the cylinder will be 3 times the volume of the cone. Put another way, the volume of the cone will be 1/3 the volume of the cylinder. So I just want us to establish that from the get-go. So basically what we're saying is this cone, because remember the volume has to do with all the space that the inside of the shape takes up, the three-dimensional space. So we could fit this cylinder, this cone, into the cylinder 3 times. That's what we're saying, right? Exactly 3 times. You're seeing some space left back now, but you would be able to fit it into that available space. This is just giving you a rough idea of what we mean. Or another idea would be if you had the cylinder, same base, same radius and height as this, you would be able to pour. Let's say you had this cone and you were able to pour some liquid into it. The first time you pour it, it would fill the cylinder 1/3 way up. The next pouring, 2/3 way up. the third pouring all the way to the top, right? So do we get that concept? Everybody clear on that part?
Yes, miss.
Okay, so that's what we're saying. All right, so now we're going to actually work out the volume of three cones. You know, I like to give each of you a chance to test your skills. So we're going to start with John, back to John. And, huh? Oh, no, it's Imani now, right? Imani.
Yes,
Imani's
miss.
turn, right? So Imani, I'm going to give you the, hold on, 1 second.
It's upstairs the screen.
Hold on. 1 second. You seen it now, Imani?
Yes, miss.
All right, so this is our radius, Imani, and
Okay.
it's 15 centimeters. This is the perpendicular height of the cone, and that's 22 centimeters. So work out for me the volume of this cone.
Okay, miss. So the volume of the cone would be 1/3 pi r squared times the height.
Mhm.
And that would be 1/3 times 3.14 times 15 squared. So bracket 15 squared times 22.
Mhm.
So um, 15 squared is 225. 225 times 3.14 is 706.5. 706.5 times 22 is 15,543. And um, 1/3 of that is 5,181 centimeters cubed.
Flat.
Yes, miss.
Okay. All right. Thank you, Imani.
Okay. Yes, no.
Okay, back to you, John.
Yeah.
So this radius, John, is 0.28 meters. The perpendicular height of the cone is 1.6 meters. So find the volume of the cone.
The volume of the cylinder is 103 the cone. Cone. The not the cone.
Cone. Cone. So always write the formula that you're using. Okay.
Times 3.14 and 0.28 meters squared times 1.6 meters.
All right. So we're holding off the units for the time being. You could write them if you want, or you can just hold them off till the end, right?
Yes, ma'am.
So work those out for me, John, and tell me what you get.
That is 0.1331.
Zero points.
0.1331.
All right, so let's round it. What's the unit?
The unit is meters cubed.
Meters cubed. Thank you, John. All right, Asar, what if it's the diameter you're given, and the diameter is 49 meters. The perpendicular height is 53 meters. What will be the volume of the cone?
It shall be pi times shall be 1 over 3 times pi times radius squared.
Mhm.
And that'll be 1 over 3 times 3.14 times 2.2 times 24.5.
So explain that 24.5.
They gave us the diameter, so we have to define the radius.
Okay, so we're given the diameter this time. The formula asks for the radius, so we not to divide the diameter by 2 to get the radius. And that's how Asar got the 24.5. All right, so times the height.
Times 53
Okay, so work those out for me. Volume is
1345.5 meters cubed.
meters cubed. All right. So I just switched up this one a little bit because we have to remember sometimes we're not given directly what we need. We have to do an additional step. So yeah, if you're given the cone and it's the radius, just plug it into the formula 1/3 pi r squared times the height. But you might be given the diameter instead, and you have to use the diameter to find the radius first. Bearing in mind, the radius is the distance from the center of the circle to the circumference, whereas the diameter is the distance from one end of the circumference all the way across the center of the circle to the other end. Therefore, the radius is half of the diameter. The diameter is twice the radius. So if it's the diameter you're given, you have to divide it by 2 first to get the radius, and then you can move on. So then, back to you, Imani. So
Yes.
this time, what we're going to be given is this time I'm going to give you the volume, and I'm going to give you the height, and I want the radius. That sound doable?
Okay, miss.
So the radius this time is unknown. I'm going to give you the perpendicular height, which is 15 meters. And I'm going to tell you that the volume is 208 meters cubed. Sorry, not square, cube.
Okay.
All right, Imani. So we need to find the
Okay,
radius
miss.
of the radius. Mhm.
Okay, so we're beginning with the um equation. So the volume equation for a cone is one third pi r squared times the height. Okay. And now we're going to substitute values that we got. So that would be 208 equals one third of 3.14 times r squared times 15. Um, Now we're going to multiply what we know. So that would be 208 equals.
Multiply these.
So 1 over 3 times 3.14 times 15. That would be 15.7. 15.7 times r squared. And we're going to divide both sides by 15.7 to get r on one side. So it would be 208 divided by 15.7 equals r squared. And 208 divided by 15.7 is 13.24. Should we round that to one decimal place, miss?
Not yet.
Okay. So 13.24 equals r squared. And we're going to find the square root of 15.24 to get r. So the square root of 13.24 is 3.63.
So R is equal to
3.63 meters.
you can round it now.
Okay, so 3.6 meters.
All right, very good, Imani. So when you're given the volume and you're asked to find the radius, you're also given the height, so you have to work backwards. So you're still using the very same formula. Nothing has changed in the formula, but you're plugging in the values that you know, and then you're isolating the variable that you need to find, which in this case is the radius. So we plugged in the volume, we plugged in pi, which we know, we plugged in the height, which we were given, and then just work out what you know already. So multiplication is associative. So we work these three, and then we isolate the radius square. Remember, the radius is still square, and we want the radius by itself. So ultimately, we need to find the square root of both sides to cancel the square from the radius, and then we get our answer. So John, you're going to get a similar one. We want the radius, the perpendicular height is 8 centimeters. The volume is 946 centimeters cubed. Check some. Okay. So how do I find the radius, John? Where's Johnny, man? I'm not hearing.
Oh, this was cute. Okay, we have to 140
So hold on, give me the formula that you're using.
it's, um, one third.
Formula. The
It's one
volume of a cone is third
one pi r
pi
squared.
r squared times the height. All right, so that is
So, okay.
one third
One third times 3.4 We have the radius.
Hmm?
We don't have the radius. Just multiply by
So just grab out the radius squared,
times 5.
and the height is
Miss 8
8.
is 8. So the volume is equal to 1 over 3 times radius on
So
4.
multiply those out.
Miss that 8.37. 8.37.
8.37.
Yes, miss.
Oh, so we were to fill in this here. Hold on. So let's just put that in where the volume is. So that was 946.
Okay, so miss to divide 9 4 6 by 8 3. Or,
By 8.37
okay,
to get
this
the
second.
radius squared.
This is that is 113.02. That's okay.
113.
Yes, miss.
So 113 flats.
Yes, miss. 113.02 flat.
Okay. So R would be the square root of that.
So the square root of 113. The square root is 10.63.
10 point. Round that.
Okay, miss, that's 11.
10.6. No, one decimal, please.
Outside.
Units.
Of centimeters squared.
Okay.
Cube.
Centimeters. Centimeters.
It's
Flat.
centimeters.
Okay. All right. So we're good to go. So Asar, your last one now. Of course, you know I'm gonna shake it up a bit, so I'm going to give you the diameter this time. It's not well, we know it just makes it a little teeny bit more complicated. Just give it another step. But we have some scholars out there who really struggle with this kind of thing. And so I always try to mix it up, throw in a little different thing so that no matter which angle they come at you from, you're able to manage, right? So,
Okay, miss.
okay, so Asar, you're getting the diameter. This time I'm going to make it come across this way. We need to find the diameter, okay? We need to find the diameter. And you're given the perpendicular height, which is 42 meters, and the volume 1,802 meters squared. All right, Asar. So I want to know what is the diameter.
Oh, so it would be 1/4. I mean 1/3.
So
Sorry,
the volume of a cone is 1/3
times pi
pi r squared
times
times the
one.
height.
Oh, okay. So the radius squared is
Plug
equal
in what you know first. So the
40.
volume is this, so it's 180.
Oh, they give it the volume.
Sorry, 1,802. Yeah, this is the volume.
Okay, 1/3.
So
One over
one
three, sorry.
third pi
Mm-hmm.
times the radius squared And the height is?
42.
Okay.
Oh, they want to find the diameter and not the volume.
Right, they give us the volume, they want the diameter.
Okay, nice.
So work out these three values that we have here, multiply them.
One hundred and 31.88 times r squared.
Mhm.
So the radius squared. The radius squared is equal to 1802 divided by 131.88.
Mhm. Which is
That is 113.66.
113
No, just 13.
or 13.6,
13.6, yeah.
13.60,
13.66.
13.66. All
The
right.
radius is equal to the root of 13.66.
So radius equal square root of 13.66. Oh my, hold on. Write this properly. 13.66. So the radius is,
The radius is equal to 3.7, sorry.
okay.
So the diameter is equal to 3.7 times 2.
All right.
Multiply
So
by
they asked us for the diameter. So we
3.
have to now multiply the radius by 2. So the diameter is equal to 3.7 times 2, which is
7.387.
round it one decimal place. One decimal place.
7.4
Unit,
meters cubed.
diameter,
Oh, meters
meters,
squared.
meters, flat. One dimension, just the length of the diameter. Are there any questions?
No question.
So everybody good? Everybody good, 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 good.
Yes, miss.
Asara, you good?
Yes, miss.
Imani, you good?
Yes, miss.
John, you good?
Yes, miss.
Ask Zane if she good.
Say you good? Yeah, no, she said yes.
Zane
Yes,
says she
ma'am.
good. All right. Well, if everybody good, we not have to draw out the thing no further, right?
No, miss.
All right. So remember tonight we have our midnight oil class. Will you be there, John?
Miss Imani, woke me up last time, miss, but she didn't wake me up too much. Imani, please wake me up.
She didn't wake you up enough.
Miss, I woke him up and he did not get up. That's on
Are
him,
you?
not me.
John
Miss, you
said
need
you
to
did.
get the phone.
John said Imani didn't wake him up enough.
Wake me up
Imani,
earlier.
Imani, this time when you wake him up, you need to make sure he sits up and get up out the bed. and wash his face. Will that be enough, John?
Yes, miss, it will be enough.
You hear
And
that, Imani?
miss, I'm not doing that. If him
Miss,
him wake up, him say him have
you're
to go
not
to class.
waking him up?
Miss,
No,
I'll wake
man.
him up, but if he's supposed to come, so he can't come.
When you wake
No,
me up,
you say if
this
you wake him up and he's still in the bed,
I did
if
tell
you
him.
wake him up and he's still in the bed, he's just gonna lie back down. Remember, he's a male, you know. Males, that's what the males are going to do, right, Asar? so, so, so you have to actually look and make sure that he gets up and go wash him face and probably drink some water.
Yes,
So I'm
ma'am.
looking forward to seeing you tonight, John, in the midnight oil class.
Yes, ma'am.
I know I will see Imani and Asar and others in the chat. Zion, Jamani, I'm seeing Lindell also. Hope I see you guys later at midnight. And we'll plow through another 60 multiple choice questions. All right, so see you later, guys.
Bye.
Bye. Bye,
Bye,
Imani.
miss.
Bye,
Bye,
Asar.
sir.
see you midnight, bro.
See you at midnight. All right, guys. So here's our schedule of live classes. Here you go. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math wrong simply because of one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So, stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.